Hi Adam, good afternoon. Yeah, please unmute yourself. Dr. Adam, please unmute yourself. You're muted.
Oh, now I think it's okay, yeah?
Yeah,
Now,
yeah.
can you hear me?
Yeah,
Okay, thank you.
right.
Okay, you give me a few seconds, I have to adjust something.
Yeah. So your talk is at 3:30.
Hi, Adam.
Hello?
Angu is here.
I'm sorry for the joining late. Let's quickly start. Basa, what is the status now? I will take or Adam will take.
So, can you see my screen?
Okay, sir. Then
Basa sir. Adam, this is Angu here. Can you hear me?
Yeah, I can hear you, but the quality is not so good.
Okay. Adam, now?
Yeah, now it's okay.
Yeah, hi, how are you?
Hello, I'm fine.
So, Adam, it's 2:30 here in India, and according to agenda, Professor Durga will be presenting the talk. Like after 1 hour, your talk is scheduled.
Okay, so I have 1 hour, yeah?
Yeah, 1 hour.
Okay, thank you very much. So something is wrong with this time zone. Okay, so I'm sorry. So
No.
okay, just let's make sure that everything is okay. So can you see my presentation now? Okay, let's say now.
yes.
We can see.
Okay, thank you very much. So now I'm stop sharing.
But you attend Professor Durga's presentation, okay? You attend, and after 1 hour, you will be presenting.
Yeah, okay. So sorry very much for this.
Yeah, no problem.
Okay. Yeah, thank you.
So welcome again to this one-day international conference on recent advances in the software engineering methodologies. So now we'll start our technical session 2. The first talk will be given by Dr. D.P. Mahapatra, Professor D.P. Mahapatra, and the topic will be recent advances in software testing methodologies. So now I request Dr. Meenakshi Sahu to introduce Professor D.P. Mahapatra, sir.
Thank you, sir, for giving the opportunity to give a brief introduction of our eminent speaker of this session. Professor Durga Prasad Mahapatra, presently professor and head of the department at Department of Computer Science and Engineering, NIT Rourkela, where he has been working since 1996. Professor Mahapatra has completed his PhD degree from IIT Kharagpur. His main research of interest are in software engineering, software testing, software reliability, software security, software project management, and program slicing. Professor Mahapatra has taken several NPTEL courses. He has supervised 15 PhD and currently supervising 6 doctoral students. He has more than 200 publications in several reputed journals and conferences. Sir is the founder of National Workshop on recent trends in software testing, which held annually for the past 14 years. He has co-authored the famous book of Discrete Mathematics with Professor C. L. Louis. Professor Mahapatra has received the Young Scientist Award by Orissa Vigyan Academy, NIT RAA Research Excellence Award for Outstanding Research Work by NIT Rourkela Alumni Association, and Sandeep Mahapatra Memorial Award for Outstanding Research by Institution of Engineers, Odisha headquarters for this contribution towards software engineering community and NIT Rourkela. Welcome, sir, and over to you. Thank you.
Okay. Thank you very much, madam, for your kind introduction. So, and first of all, I apologize for the delay caused because there are some urgent work and I was traveling. So, anyway, I will adjust the time. Let me share the screen, but it is not. I am not able to share the screen. So, Basa or Sanghu, can you help me? Not able to where it is.
So there is one arrow bottom.
Oh, yes, that I had seen. Yes, that I had seen.
Showing
Sir,
up arrow.
Yes, that I had seen. Let's see.
Hmm.
That's I have seen. Let's see. It's working or not.
You press on your entire screen. Huh,
Yes. Now
yes,
just
sir. Now it is presenting, sir.
okay. Let me see. Okay.
Make it slideshow, sir.
Just doing it. Okay. So 38 only. No, we'll take the other one. Introduction. Hello. 1 minute, please. Introduction. PHI. Yes. Okay. Oh, this is Hydrox. Okay. So we'll start quickly. This topic on both black box and white box testing. I hope now the screen is visible. Is it? Anyone please respond. Is it visible?
No, sir. No, sir.
Not visible. Okay.
Please share. Click on that.
Again, we'll then do. Let me go to that one. Your entire screen. So now is it visible? Let's see.
No, sir. Again, it's gone. So
Now not visible.
no, it's
Okay.
not visible, sir.
Okay. Oh, okay. I'm just again trying. It was just coming, but
Otherwise, you will send me, sir. Will
no. It will come. Just see. It should come actually. Share the complete screen. Then we'll do this thing.
yes, entire screen, sir.
Yes. Now it is visible.
Yes.
Okay.
Like, sir, make it slideshow.
Yes. And now
Yes,
visible.
yes, sir.
Okay. Oh, okay. So, very good afternoon to all of you. We'll quickly look at only the important points. I hope most of the audience, they have studied a paper on software engineering, either in their graduation or post-graduation. So the fundamental things I will skip. I will try to cover more of the examples by using which you can generate what test cases you can perform testing of the software. That will emphasize so that will be more interactive. Okay. So I'll say only actually that there are different or several types of defect reduction techniques. How to what identify the defects, how to reduce them, We may not completely make a program 100% error free. We should try to make it to reduce the defects as much as possible. So several techniques are there, such as review, software testing, formal verification, and through a proper development process by using systematic methodologies and so on. So today we'll highlight only the testing aspects. So before going to this importance of testing, I'll just quickly say 1 or 2 minutes why testing is so much important. I had given a simple picture here. You can see that on the left hand side there's a rocket called as Ariane 5 rocket, and you saw in the second one it was just launched, but it was destroyed. It was self-destructed just 37 seconds after its launching. And you know why it was destroyed? See, the reason is that a very minor bug, a control software bug which went undetected from the so many eyes of the engineers, those who are involved. And what are the bug? You can see, about conversion. So like integers to float, or this float to integer, like this. So in this Ariane software, that rocket, they have used a software to convert a 64-bit floating point number to a 16-bit signed integer value. And there's a specific range, say plus something to minus something, that range, but this was not falling within that range. And so since this conversion from 64-bit floating point number to 16-bit signed integer value, it was not coming within that specific range, so it has caused an exception. And this exception, for handling that, in Java you are using try catch block etc. for handling exceptions. So they have not written a specific routine or subroutine for this exception, handling this exception. As a result, this has an exception has been caused, and this is leading to a serious problem. And the range you can see from any of the books, and this floating point number, it was larger than that prescribed range. It was larger than the prescribed range of 32767. So now this has led to an exception. So the efficiency considerations, they had led to disabling of the exception handler. So that exception handler, they have not properly designed. It was disabled, and while taking this exception handler was disabled while the conversion was taking place from 64-bit floating point to 16-bit signed integer. So there's a problem with this during the testing, and how much money they have wasted, they have lost. So around $1 billion was spent in making this Ariane rocket, and that was just destroyed. It has gone into sea just 37 seconds after its launching. So this shows why testing is so important. Had it been properly, they could have tested the software, embedded software within that rocket. Perhaps this $1 billion won't have been destroyed. So this shows the importance of software testing. Okay. How do you test a program? I hope you have already known. We will not give much emphasis on this. First, you have to supply input data to the program. Then you have to observe the output. Then match whether the program it is behaving as you are expecting or not. If there is a difference between the actual output and the expected output, then you say there is some error. But if they are matching, then no error is there, and you can proceed further. So if the program behaves as you are expecting, then that's fine. But if the program does not behave as you have expected, then you have to write down the conditions under which the program has failed. So this leads to presence of some errors, and then later on you debug those errors and correct it. So in this way you can test a program. Okay, this is how you can test a program. And I will not take away. There so many other things are there. We don't have time to see this. And among the development phases, testing, it takes the maximum amount of effort. Almost 50% of the development effort is spent in these testing activities. Okay. And nowadays, testing is getting more and more complex and sophisticated, isn't it? Why? There are few reasons, like larger, and the present day programs are much more larger and they're much more complex. You see, previously when you are going to those who have used this railway reservation. See, previously while we were children, we have to go to the counter and stood there hours together to get a train ticket reserved. But nowadays, you see, you need not go anywhere else. You sitting in your home, you can book the train tickets, flight tickets, etc. Have you imagined what is the size of that program? How many functionalities are there? So many functionalities are there. It's a very complex programs. These are larger programs and complex programs. And if the programs are larger and more complex, obviously testing will become much more difficult. Similarly, previously only Fortran, Pascal, COBOL were there. But as this paradigm, as the technology is changing, then gradually new programming paradigms are coming. Previously only procedural programming paradigms, now object-oriented, aspect-oriented, feature-oriented, so many new programming paradigms are coming. And in order to test them, you have to put much more effort. Please, simple thing, how much effort you are putting for testing a procedure program, much more effort is required to test an object-oriented program. You know, the features of object-oriented programming language are what? Inheritance, polymorphism, dynamic binding, and so on. Do you think that these are the greatest features of object-oriented programming language? But side by side, they pose special difficulties in testing the software. So this makes another challenge for testing these softwares. So these are some of the overview of the testing activities. First, what you have to do, as I have already told you, you have to supply input data. So that means you have to supply input test data, and the collection of such test data we call a test suite. Then run the test cases and observe the results to detect the failures. So what are the test cases? I have already told you test suite means collection of test cases. Run the test cases, then observe the results to detect the failures. Then you have to debug to locate the errors. And finally, you have to correct the errors. These are the overall testing activities. Okay. So these definitions, I will not spend time on this. What is an error? What is an fault? Or what is a fault? Or what are failures? These are easy things. But please remember that just mere presence of an error may not lead to a failure. Always, whenever an error is there, it may not lead to a failure. So don't confuse. Even if an error is there, it may not lead to a failure. I'll give a very simple example here. You must know, called as pesticide effect. The farmers are spraying pesticides in their fields, maybe nitrogen or something, urea or so. There are several insects. So if the farm has just sprayed some nitrogen or urea, and you see some of the insects will die, but some other insects, they will try to manage with that. Their immunity is so strong, they will try to survive. So now the farmer, how many amount of the same pesticide he applies, maybe same urea, same nitrogen, they cannot be killed. He has to change his pesticide. He has to use more powerful pesticide and different dose. Then only those can be detected. So similar thing happens in software. If in your software 10 bugs are there, you have applied one testing strategy, you have detected suppose 7. Now the same and 3 are left. So if you apply the same testing technique so many times, you cannot detect them. You have to change your testing strategy. Then only you can detect the remaining errors. So this is very much analogous or similar to the pesticide effect. Okay. So I will give a simple example to this. So before that, let me tell that the errors which escape is fault detection technique cannot be detected by further applications of that same technique. You have to change the technique, then only you can detect the remaining errors. This is known as pesticide effect. I am giving a very simple example. Let us assume that we are having 4 fault detection techniques, and let us assume that there are altogether 1000 bugs. Each one detects how many? Say 70% bugs. Then the question is, how many bugs would still remain? Very simple. How many types? 4 types. How many total bugs? 1000. 70% bugs are detected. How many remaining? 30%. So 1000 into 0.3 to the power 4. Coming to be how much? Nearly about 81 number of bugs will still remain. So in order to detect these 81 bugs, even if you apply the same 4 fault detection techniques, they cannot detect. You have to add another technique. You have to apply another technique or another 2-3 techniques, whatever that, to detect those 81 bugs. So this is a direct, simple, straightforward application of pesticide effect. Okay. So these things are very much easy. You just read yourself. I am just giving what do you mean by test case, what do you mean by test suite. So normally we have to test a software using a set of carefully designed test cases. And what is a test case? I will just shortly say. And the set of all the test cases is called for test suite. So test suite means it is a collection of the what test cases. So what is a test case? Very simple. It is a triplet called as ISO, where I represents the input data to the system, S represents in which state you are supplying the input data, and O represents the expected output of the system. Then what we have to do? After supplying the input test data, observe the actual output, compare with the expected output, what is the difference? So then you can detect the errors. So this is how the test cases and test suites are defined. Okay. And what is our objective of testing? The aim of testing is to identify all defects in a software product, but this is theoretically, but in practice, even if after you are applying testing to large extent, even after you are conducting thorough testing, you cannot give guarantee that the software is error-free. Why? The reason is simple. The input domain is very large. Your software might work for x is equal input x is equal to 2 and x is equal to 3. But in between 2 and 3, you can see there are a large number of what real numbers are there, and your software may not work for each and every real number. So making a software 100% error-free may be very, very difficult. Okay. So that's why what we should do. So the reason I have already told you why it is not possible to make 100% error-free a software, because the input data domain of most software products is very, very large. So that's why it is not practical to test the software exhaustively with each input data value. Testing does, however, expose many errors. So still then we have to use testing technique. It can expose as many errors as possible. Okay. So these are some of these regarding fundamentals of testing. There are 3 kinds of testing you have already known: unit testing, integration testing, and system testing. Unit testing is carried out while you are writing the code. It is known as coding and unit testing. While you are writing a single module, you have to test it in isolation, because if all the modules you will test together, it is very much difficult to determine that which module has the error, which module contains the error. That's why as soon as you write a single module, you immediately test it. Okay. And this is unit testing. And in integration testing, what you have to do? So now suppose you have developed or coded say 100 modules. Then you have to, and those 100 modules you have already unit tested. So now these modules, they have to be integrated in steps according to an integration plan. Don't integrate them haphazardly. Say module 1 will be connected with module 2, module 3 will be connected with module 4, like this. So modules have to be integrated in steps according to some integration plan. Then the partially integrated system is tested at each integration step. This is called as integration testing. And in system testing, what we are doing? We are validating a fully developed system against what? Against the requirements. And first you have already prepared the SRS documents. All the requirements are written in the SRS document. So finally, after conducting the integration testing, you have to perform system testing in order to validate the fully developed system against what? Against the requirements as mentioned in the SRS document. Okay. So our objective is we have to design, I have already told you, exhaustive testing of any non-trivial system is very, very impractical, because the input data domain is very, very large. So what should be our objective? We should design an optimal test suite where the size is reasonable, not it is very large. So we have to design an optimal test suite of a reasonable size, and at the same time, it uncovers, it detects as many errors as possible. Okay. So these are the 2 major sub-objectives. The test suite size should not be very large. It should be of reasonable size, but at the same time, it should detect as many errors as possible. Okay. Okay. So now I will take up actually the types of testing. Then I will take some few examples. Okay. These are the minor things. I will not. Okay. You can take this one. So testing a system using a large number of randomly selected test cases, it does not mean that errors in the system will be uncovered. So you can take a simple example I have shown here. Suppose you have to find out the maximum of two integers x and y, and suppose the programmer has written this code that if x is greater than y, marks is equal to x, else also marks is equal to x. It's simple error. So if you take that, the test suit as x equal to 3, y is equal to 2, and x is equal to 2, y is equal to 3, you can detect the error, because in one case x is greater than y, in another case x is less than y. So the error can be easily found out. So this is the test suit: x equal to 3, y is equal to 2, x equal to y is equal to 3. So two test cases I have taken to detect the error. Now what I have done, suppose I have taken 3 test cases, but I have just haphazardly designed the test cases, and in every test case x is greater than y. So if you take these test cases, obviously this error in this code cannot be detected. So the point of speaking is that if you just haphazardly prepare or develop a test suite, and even if the size is large, it may not detect the error. For example, here 3 test cases, in the second case, in the first case 2 test cases, but the first case it detects the errors. But the second case, even if there are 3 test cases, it does not detect the error, because every time x is greater than y, so it cannot detect the error. Okay. So we have to follow systematic approaches. Systematic approaches are required to design an optimal test suite, and each test case in this test suite, it should detect what? Different errors. So what should be your objective? You should design the test cases in such a way that each test case in the test suite should detect different errors. Okay. There are different approaches for designing test cases. One is black box approach, another is white box approach, and one is gray box approach. These fundamental things you have known. I will not take much time on this. We'll directly go to example on black box approach. In black box testing, what we are doing? We are designing test cases using only the functional specification of the software. Where the functional specification written? It is written in the SRS document. And here we design the test cases without having any knowledge of the internal structure of the software. We do not know what is written inside the structure, inside the software. The statements you do not know. So in black box testing, the test cases are designed using only the functional specification of the software without having any knowledge of the internal structure of the software. So since we design the test cases only by using the functional specification, that's why this testing is also known as functional testing. Okay. Several black box testing techniques are there, such as equivalence class partitioning, boundary value analysis, state table based testing, decision table based testing, cause effect graph based testing, orthogonal array testing, positive negative testing, and so on. We are running out of time. I'll try to cover only some examples on these first 2, equivalence class partitioning and boundary value analysis. Okay. Acha, before going to this particular techniques, one more technique just we will see: white box testing. In black box testing, we do not require the knowledge of the knowledge of the internal structure of the software. But in white box testing, we have to design test cases and which will require the knowledge about the internal structure of the software. We have to know what are the statements written in the program. We have to know the details, the internal structure of the program, or the detailed structure of the program. So in white box testing, designing white box test cases requires the knowledge about the internal structure of the software. So white box testing is also called as structural testing, because we have to know the internal structure of the software. Okay. Several white box testing techniques are there, such as statement coverage, branch coverage, path coverage, condition coverage, MCDC coverage, mutation testing, data flow based testing, and so on. So time is not there. Sometimes, if possible, we will discuss the white box testing techniques. Today, we will only discuss about the black box testing, few techniques. So here we have written, then question arises, why should we go for both black box and white box? Either I can go for only black box or white box. No, because if you only take black box testing, then it will be impossible to write a test case for every possible set of inputs and outputs. Similarly, if you are only performing black box testing, some code parts may not be reachable. So I have to go for white box testing. If you are only using black box testing, it will not tell you if extra functionality has been implemented that can be known if whether you have implemented if any extra functionality that can be known by using the white box testing strategy. Similarly, if somebody will say that I have performed only white box testing, I should go for a black box testing, because it does not address the question of whether or not a program matches the specification. Your program may be correct, but the output is not matching with your requirements. Who will use that one? So we have to go for black box testing. Why white box testing is not sufficient? Because it does not address the question of whether or not a program matches the specification. Similarly, if you have only performed white box testing, it does not tell you if all of the functionality has been implemented or not. Similarly, white box testing, it does not discover the missing program logic. If the program logic is missing, simply white box testing, it cannot say. We have to go for black box testing. That's why the black box testing and white box testing techniques are complementary to each other, and we should perform both the techniques simultaneously. Okay. And gray box or model-based testing, here we use the features of both black box and white box testing. So in gray box testing, the test cases are designed in between. I have already told you, black box testing test cases are designed from the requirement specification, SRS document. In white box testing, test cases are designed from the code. So what is remaining in between? You know, SDLC model. First is SRS document or requirement specification, then design, then coding. So between requirement specification and coding, what is there? Design. So if we can design test cases from the design documents, so that is known as gray box testing or model-based testing. In gray box testing, test cases are designed from the design documents such as data flow diagrams, UML diagrams, ER diagrams, etc. Gray box testing is also called as model-based testing because you are using several models such as data flow diagram, UML diagrams, ER diagrams, etc. Normally, this gray box testing or model-based testing is used for testing of object-oriented systems. Okay. So now we'll quickly go for this black box testing. What is black box testing? We have already discussed. Here, as if the software system, it is viewed as a black box. Only we look at the input test data, and then we'll design test cases. We'll observe the output results. That's why this is known as black box testing. Here, the software system is viewed as a black box. Let's see what kind of errors can be detected by black box testing. So black box testing attempts to find errors in the following categories. Using black box testing, we can know, using black box testing, we can know the followings to test the modules independently. Also to test the functional validity of the software so that whether incorrect or missing functions can be recognized. For that also we can use black box testing. And black box testing also can be used to look for the interface errors. Interface errors means when module A is interfaced with module B. During that interfacing, some errors might occur. Those errors can be detected by using black box testing. Okay. Similarly, to test the system behavior and check its performance. If you want to check the system behavior, whether it is accommodating all the data types or not, whether it handles the desired volume or not, and you want to check the usability, reliability, etc. So to test the system behavior and the check its performance, we can use black box testing. Similarly, to test the maximum load that the system can bear or stress on the system, we can go for black box testing. And to test the software so that the user or the customer accept the system within defined acceptable limits, you can also use black box testing. Okay. Several black box testing techniques I have already told you. So today we'll take up only these two techniques. These techniques most of you have already known. I will only give some examples to what illustrate this. Equivalence class partitioning and boundary value analysis. So equivalence class partitioning, how does it work? What are the steps? First, input values to a program, they are partitioned into some classes they call as equivalence classes. So there are several input values. You have to classify them. You have to partition them into some classes known as equivalence classes. Then the question is, how will do the partitioning? Partitioning is done in such a way that the program behaves in similar ways to every input value belonging to an equivalence class. So how many values may be there in an equivalence class? it is assumed that if a program is behaving in which manner for one particular value in a class, it will behave in the similar way for the other values. I will give some examples. So why define equivalence classes? What are the reasons? We have to test the code with just one representative value from each equivalence class. Because we are having less time, we cannot, and the input domain is very large, we cannot test each and every possible value. So what we have to do, we have to test the code with just one representative value from each equivalence class. Because testing the code with just one representative value from each equivalence class is as good as testing using any other values from the equivalence classes. So that's why you just test with one value, you will get similar type of results if you will take the other value. No need to take the other value, just one value from the class if you will take for testing, that will be sufficient. Then the question is, how do you determine the equivalence classes? Let's see, we have to first examine the input data. So few general guidelines are given for the equivalence classes, which are as follows. If the input data to the program is specified by the range of values, maybe between, for example, 1 to 5,000, then what will the equivalence classes? Three equivalence classes. One is valid, that means any number between 1 to 5,000, and two are invalid. That means one is less than 1, I mean all negative values, and one is containing the values greater than 5,000, 5,001, 5,002, 5,002, like that. So in this case, it is divided into three equivalence classes. If the input data to the program is specified by a range of values, for example, numbers between 1 to 5,000, then one valid and two invalid equivalence classes are defined. But another case is there, if the input by an enumerated set of values. I hope in C you must have known enumerated data type. For example, the days in a week, the months in a year, these are all examples of enumerated data types. If input is an enumerated set of values, for example, out of A, B, C, one will be there, we have to choose. Then two equivalence classes you can construct. One equivalence class for the valid input values and another equivalence class for the invalid input values. In that way, you have to define two equivalence classes. One equivalence class for the valid input values and another equivalence class for the invalid input values. Okay. Okay. Now let's quickly take a small example. That suppose a program, it reads an input value in the range of 1 and 5,000. You have to compute the square root of the input number. So then what will the test cases? Using equivalence partitioning, you can get three equivalence classes. One is the set of negative integers like this, invalid, and set of integers in the range of 1 and 5,000. And each one is one is the set of integers larger than 5,000. Now, so the test suite then must include the representative values from each of the three equivalence classes. So I have given a sample test suite. A possible test suite can be as follows: one negative value may be -5, then 500. That means in between the value, in between the range 1 to 5,000, and one value is greater than 5,000, so 6,000. So this is one possible test suite for this given program of finding the square root of a number. Okay. So more examples on equivalence class partition-based testing we can consider. So these are very important. Please try to understand. So let's see this example. Just 1 minute, please. I have taken very good examples now. Wherever, let's see. Any doubt till now? If any doubt, you can just ask me. Otherwise, you will take some good examples to apply actually in real life how you can apply the equivalence class partitioning method. So, any doubt till now? If anybody else, otherwise I will go to the different examples. A set of examples I have constructed. First example: design black box test cases for the following program. What is that program? Suppose you have to write a program which checks whether two straight lines they intersect and print their point of intersection or not. So two straight lines are there, whether they are intersecting or not. If intersecting, what is the point of intersection? I want to design some test suits. You know that the straight line, how can represent a straight line? Very straightforward. Y is equal to mx plus c, isn't it? That represents a straight line. So now you know straight lines are represented or given in the form of m1 c1 and m2 c2. Those slope and intercept, you know. So two straight lines. So one is m1 is represented with m1 c1, that is y1 is equal to mx1 plus c, and another is y2 is equal to mx2 plus c. Or you can say y1 is equal to what m1 x1 plus c1, y2 is equal to m2 x2 plus c2. So the straight lines are given in the form of m1 c1 and m2 c2. So what are the equivalence classes? Now I have to identify. So you see, this is a typical case. So you have to identify how to find out the equivalence classes. Here you have to identify what are the possible classes, what are the equivalence classes, what are the possibilities. You can see three possibilities. You can see one is a valid case. That means two straight lines that are intersecting at a single point. One case. Another case, they are not intersecting, they are just parallel. Okay. Another case, they are coincident. One straight line is coincident on another test, another one. Okay. So accordingly, three equivalence classes I can get. First case one, the lines are parallel. So what is the condition so that two lines will be parallel? M1 must be equal to M2. So what could be a possible test case? How I am writing the test cases? M1 C1 and M2 C2. Two lines should be parallel, in which case I have to take M1 is equal to M2. So I have taken 1, 2 and 1, 5. See, M1 and M2 are same, 1, 2 and 1, 5. Second possibility is this is a what? Invalid equivalence class. Another one, it is also invalid because we want one point of intersection. So two coincident lines, how can represent coincident lines? That M1 is equal to M2 and C1 is equal to C2. Then we say that two lines are coincident. So what are the points then? 2, 3 and 2, 3. M1 is equal to M2 and C1 is equal to C2. So these two are invalid equivalence. These two are invalid equivalence classes. So one is a valid one. Which one is valid? That two straight lines, they intersect at the same point. So lines intersecting at one point. For that, what is the condition? M1 must not be equal to M2. So accordingly, I have taken a test case 2536 where M1 is not equal to M2. So altogether there are three valid. What we are taking. Okay, I'm just sorry. So here we are finding out what two straight lines intersect or not. So here the two parallel lines, of course, they are not they cannot intersect. So these can be considered as invalid. And the coincident line, they are intersecting at multiple points, and lines intersecting at one point. This one 2536 where M1 is not equal to M2. The two lines, they intersect at one point. So we can say that there are two, not three, I'm sorry, two valid equivalence classes and one invalid equivalence class we have taken. You may include one more valid equivalence classes also. So there are here you can see this boundary testing I have not told, I will say. So what is the final test suit? For this I have taken these are the final test suit 1215, 2323 and 2536. So this is my final test suit. Okay. In this way, for this problem, I can generate the final test suit. Any doubt, please? So similar type of examples you can construct yourself. Now let us take one more example. Okay. So this is, you have taken the straight line. Now I am taking another one, intersection of two circles. So question is, you have to design some black box test cases for the following program. what this program says? The program finds the points of intersection of two circles. What are the two circles? The two circles may or may not intersect. So you have to identify what are the possible equivalence classes. From your 10th class knowledge of geometry, you can say that two circles may touch at one point. Two circles may intersect at 2 points. Two circles may not intersect at all. One circle may be overlapped to the another one. And other cases you might know concentric circles. That means same circle, same point, and radius is different. So how to represent then the circles? So here I require two things. The points are x1, y1, x2, y2. R1 is the radius of the first circle, R2 is the radius of the second circle, and D the distance. So these are, I have identified few equivalence classes. If you can add more equivalence classes, that also fine. This is only for your understanding. So first test case, see, in my first example, I have already shown you the test cases, how to write down the test cases. First, I have designed the equivalence classes. Then I have constructed the test cases. Finally, I got this resultant test suite. In my subsequent examples, I will not write down the test cases. I will only write down the equivalence classes, and leaving you as exercise, you have to find out what are the test cases. I will only identify the equivalence classes. Okay. So in this case, I have identified these are the following equivalence classes. That the two circles, they are not intersecting. This is one possible class. This is one possible equivalence class. For this, what is the condition? That R1 plus R2, this radius 1 plus radius 2 should be less than the distance between the 2 points, x1, y1 and x2, y2. Then they will not intersect. If R1 plus R2 is equal to distance, then the next possibility, that means the two circles, they are touching at 1 point only. It is possible that two circles may intersect at 2 points. What is the formula? What the condition? Just R1 plus R2 should be greater than the distance. It is also possible that one more equivalence class, the two circles, they are overlapping. For that, what is the condition? You should choose the points in such a way that distance D should be equal to 0 and the radius 1 should be equal to radius 2. Similarly, concentric circles, you can see radius R11 is not equal to R2, but distance is equal to 0. So maybe concentric circles. And you can say that another invalid circles. You are not taking x1, y1, something x1, y1, z1, x2, y2, z2 like that. They are not at all, they do the points, they do not at all represent circles. So invalid circles. So in this way, you have identified the equivalence classes. Then the next step is design the test cases. For the first case, we have already seen how the test cases are written. So similarly, you write down the test cases for this one. This I am leaving as an exercise for you. Okay. So these two we have taken from geometry. Now let us take two examples from algebra, how to design the test cases. So you know how to solve the quadratic equations. Suppose the quadratic equation is the form of ax square plus bx plus c. How many input values it takes? A, B, and C. Suppose they are all floating point values. Okay. For example, the input value may be A is 7.7, B is 3.3, C is 4.5. And I have to write down a program to test this. Sorry, I have to write a program, then I have to design some test cases. So what are the equivalence classes? You can see the equivalence classes are as follows. You know, what is the solution of this quadratic equation? Everything that is minus x plus minus root over of b square minus 4ac divided by 2a, isn't it? That is the solution of a quadratic equation. And you know, the whole solution will depend upon the d value, that is b square minus 4ac root over. So the whole value, the whole result will depend upon this value, b square minus 4ac root over. So now you see, what are the equivalence classes? The equivalence classes are as follows. If that may be a possibility, b square may be equal to 4ac, b square might be greater than 4ac, b square may be less than 4ac. So if b square is equal to 4ac, you have to choose the input values of a, b, c in such a way that b square should be equal to 4ac. For example, a is equal to 2, b is equal to 4, a is equal to 2.0, b is equal to 4.0, c is equal to 2.0, because these are all floating point values. Second equivalence class is b square is greater than 4ac. So inputs you should choose the input values a, b, c in such a way that a is equal to 2.0, b is equal to 5.0, c is equal to 2.0. Similarly, b square is less than 4ac. Choose the values of a, b, c in such a way that the value of a, b, c in such a way that b square is less than 4ac. So a is equal to 2.0, b is equal to 3.0, and c is equal to 2.0. And another one is every time you try to consider some invalid values. For example, you choose the values of a, b, c in such a way that they do not represent at all a quadratic equation. For example, if a is 0, b is 0, whatever value of c may be, it cannot be a quadratic equation. So these are the equivalence classes, and the test cases here already I have written. So this is the method. These are the test cases. This is the method by using which you can write down the test cases for solving the quadratic equations. One more example we'll take from linear algebra. You know how to solve linear equations. So question is how to design the black box test cases for the following program. Okay. Design the black box test cases for the following program. That is, the program solves linear equations in up to 10 independent variables. Suppose you normally in up to in your plus 2 or 10th or plus 2, you have taken maybe up to 4 or 5 independent variables. Suppose maximum will take the linear equations up to 10 independent variables. We have to design black box test cases for the following program. The program solves linear equations in up to 10 independent variables. And for example, this is the set of what linear equations I have given. Then question is how to design the test cases. But first step is identify the equivalence classes. Then the second step is design the test cases. So what could be the equivalence classes here? First, I can divide into two categories: valid equivalence classes and invalid equivalence classes. What could be the valid equivalence classes? And you know, in case of the in case of solving the linear equations, there are three important possibilities which are coming under valid equivalence classes. One possible solution, one possible way is, or one possible result is there can be many solutions, there can be no solutions, there can be unique solution. And you know, the most easiest one is unique solution. If number of variables is equal to number of equations, then you say, okay, only exactly one solution, that unique solution. If the number of variables is less than number of equations, then many solutions may exist. If number of variables is greater than number of equations, then no solutions exist. Okay, these are all valid equivalence classes. Accordingly, you write down the test cases yourself. And in invalid equivalence classes, what could be the possibilities? Question says, in my question given the linear equations up to 10 independent variables. Somebody has written 11 independent variables, or linear equations using 15 independent variables. Those will not accept. So that is an invalid equivalence class. Similarly, an invalid equation where say number of values 0, no variables, just 2 plus 3 plus 5 something, no variables at all. So this is an invalid equation. So these are the valid equivalence classes and invalid equivalence classes. So then write down the test cases accordingly yourself. Okay. So this is two examples we have taken from linear algebra. Two examples we have taken from your which one? Geometry. So one more example I want to take because you are postgraduate students, you have to design, you have to develop some projects. So let's take quickly a small one. So that is, you know, a simplest project is library information system. In library information system, if you are designing a software for the library information system, there are several functionalities, maybe issue book, return book, search a book, then your query book, I mean search a book, add member, delete member, add book, delete book, etc. So I will take only one functionality and write down how to write, and I will show how to write down the test cases. Design black box test cases for the option query book using a keyword. Suppose you will just give the name of the author name or title of the book, and it will show you whether the book is present or not. If it present, where, which is the rack number, like that. So if you can see, what are the first step is identify the equivalence classes. Then second step is identify then design the test cases. Let's identify the equivalence classes. The equivalence classes and the corresponding test cases are as follows. You can see there can be three possible equivalence classes. So first equivalence class, that means first possibility is that the book is not present in the catalog at all. So what is the test case? So I have given the title of the book, software engineering, and while you are searching, that is not available, not present. Another one, the first equivalence class, the book is not present in the catalog, you don't have in the library. Second one possibility is that, second equivalence class is that book is present in the catalog, but all are issued to the students or faculty members. So currently no book available. So what will, because I have told test case means what? Normally input and the output. State here is state remains almost constant in this case. Okay, state remains here constant. So input is what? Title, software engineering. And what are the output? It is present. And 15 issued. There are only 15 copies. All 15 are issued. And hence, right now, no book is available on software engineering. And the last one is present in the catalog, as well as right now it is present. What could the test case? Input, the title software engineering. Output is present. And how many? 10 issued and 5 are available, because 15 are there, so 10 issued and 5 are available. If you want to make it more sophisticated, one more value you can write the rack number, say rack number 5. So 5 are available in rack number 5. So another value you can write rack number 5. In this way, you can design test cases for a functionality in a project. For example, here we have taken the library information system and designed the black box test cases for the query book option, for the query book function. All right. So in this way, we can design the test cases using equivalence class partitioning. Okay. So any doubt till now? So one more example I have taken. A program reads 3 numbers ABC with a range 1 to 50 and prints the largest number among these 3. We have to design the black box test cases for this program using equivalence class partitioning. So there are this, we partition the domain of input are the valid input values and invalid values. Like see, these are the classes. In A, it lies between 1 to 50, B lies between 1 to 50, C lies between 1 to 50. So another class is that, another class will be what? A is less than 1, similarly B is less than 1, and C is less than 1. Another invalid class you can see, A is greater than 50, B is greater than 50, and C is greater than 50. So in this way, you can identify what? The equivalence classes. Once you have, so here I have identified how many? 9 equivalence classes, both containing containing both the valid and invalid equivalence classes, and then you can design the test cases. Okay, so then you see I have designed the test cases taking one value from a variance ABC, one possible value we have taken. These are the expected results and what classes they have covered, whether I1, I2, I3, 9 classes I have shown. So which classes they have covered I have written. Very simple. Okay. Similarly, this is another one. We can derive another set of equivalence classes based on some possibilities for 3 integers. Like in one case, A is greater than B, A is greater than C. Another case, B is greater than A, B is greater than C. Another case, C is greater than A and C is greater than B. So this is another way of also identifying the equivalence classes. These are these rules. So finally, you can design the test cases like this. Okay. In this way, you can design the test cases following this approach. So still another example, the program determines the next date in the calendar and its input is entered in the form of the following range, like month lies between 1 to 12, days lies between 1 to 31, year lies between 1900 to 2025, and the output would be the what is the next date or an error if or an error message showing invalid date. So we have to design test cases using equivalence class partitioning method. Okay. So first what we have to do, we have to identify the valid input. First we partition the domain of the input in terms of valid input values and invalid values, getting the following classes. So like you see, in first case, month in between 1 to 12. Second class, day lies between 1 to 31. Third class, year lies between 1900 to 2025. And then these are all valid classes. Then you have to take invalid classes. Suppose somebody has given a month -1 or -2, so m less than 1, invalid class. Month greater than 12, say month somebody has given 20, invalid class. Day less than 1, day greater than 31, invalid classes. Year less than 1900, year greater than 2025, because in our question it is given year lies between 1900 to 2025. So if somebody has given year less than 1900 or greater than 2025, these are also invalid classes. Okay. So in this way, we have identified the equivalence classes and then we have designed the test cases. So these are the test cases. You see, for the first one, suppose test case, please remember every test case should have an ID. So first test case 1, month suppose 5, day is 20, year is 1996. So what should the expected result? Next day. Next day is what? 21, 21st, 5, 1996. So this is valid and it is covering the classes I1, I2, I3. These one. These valid cases, these are valid cases or these are the valid classes. Accordingly, these are the test cases. This is the valid test case. All others I have to take, I have to also cover the other classes from every class, from every equivalence class. I have taken one sample value. You have got the expected result. These are all invalid inputs. Okay. So in this way, you can design test cases for this calendar problem, for this what maybe to know the next date. To know the next date, you can generate test cases in this way. Okay. We have taken one more example. So you want to know that an angle, whether it lies in between a program takes an angle as input within range 0 to 360 and determines in which quadrant the angle lies. So you have to design test cases using equivalence class partitioning method. So I have given two methods. First method, we partition the domain of the input as valid and invalid classes. And here like this, you can see first equivalence class, angle lies between 0 to 360. This is valid class. What are the possible invalid classes? If angle is less than 0, angle is greater than 360, these are all invalid classes. And the test cases are like this. So suppose I have every test case has an ID. Suppose I have taken angle 50. So it should be in first quadrant and it's covering class I1. If less than 1 or greater than 360, these are invalid input values and they cover maybe I2 and I3 respectively. So this is how we can generate the test cases based on equivalence partitioning. There is another method for this. So the classes can also be prepared based on the output criteria shown below. Maybe if if you want to say that you want to see that whether the angle lies in the first quadrant or not. That means if angle is lying between 0 to 90, then first class. Angle lying between 91 to 180, second class. Angle lying between 181 to 270, third class. Third quadrant, angle lies between 271 to 360. It is called as it should be the expected output should be fourth quadrant. If you are giving invalid angle, say more than something 360 or less than 0, that should be invalid angle. Okay. But O5 may not be sufficient because there are two sub cases, two possibilities. Angle may be less than 1 and angle may be greater than 360. So you can divide into two more cases, like angle greater than 360 and angle less than 0. So the sub-equivalence classes I have taken, one is O51 and the O52. Okay. So these are the test cases for this. Every test case has some ID. Different angles I have chosen so that every class will be executed, will be considered at least once. So first one is first four are all valid. They are covering classes O1, O2, O3, O4. And last two are invalid. They are covering the equivalence classes, invalid equivalence classes O51 and O52. All right. Anyway, all right. So this is something about the examples based on the equivalence partitioning method. All right. So these are the examples we have seen based on this equivalence partitioning method. Actually, next comes boundary value analysis. We are running out of time, so I'm sorry. We have to stop here because the other expert is waiting. But the slides I have given, many examples I have taken, you can read yourself. I have to stop here because I am I have already taken more time, so we have to stop here. Now let's quickly take a few questions if possible. If somebody is asking any doubt, please ask. I can take 2-3 minutes on the questions.
Thank you very much, sir. So, any questions from anybody?
Any questions, I will be happy to answer. The slides I will try to give to Dr. Basa, who will share with you. And
Sure.
Any questions, if anybody wants to ask, can ask now. So I hope either you have understood everything or you have not. You have understood nothing.
No, sir. Actually, you explained so well. So I don't think anybody has any doubt because your examples are very clearly understandable examples. So I think everybody will definitely understand. And thank you very much for your very informative talk, sir. And we'll looking forward in future also, sir. So.
Okay, thank you very much, Dr. Basa, for giving an opportunity to deliver talk in the software testing area. Thank you very much. So Adam sir, sorry for making you waiting for more time. Professor Adam is already waiting.
I think Dr. Adam has left.
Okay, so
Dr. Godbole,
Sir.
Can put some HTML things into the
Adam, Dr. Adam has left, I think. So,
Let me contact her.
yeah, please.
Contact him, sorry. Adam.
you can give 5 minutes break to the participants so that
Yeah, that will be better.
and by this time Sangratna will contact Professor Adam and then you can proceed. That will be better. By this time, if anybody
Sure,
wants to ask any question or any doubt, you can ask. Others may take leave or break for 5 minutes till the new speaker joins.
Adam, we are starting. Please join.
Sangu, what he told?
Sir, just I have sent one voicemail.
Okay. Okay, please wait and then 5 minutes break you give to the participants. So when you will join, you can start again.
Sure, sir. Sure, sir.
So thank you very much for your patientful hearing. Thank you very much.
Thank you, sir.
Okay.
Thank you, sir. Thank you.
Okay.
Okay, Adam
Dear participants, please wait till
Adam is joining in 1 minute.
Adam joined.
Yeah.
Okay.
Adam, can you unmute?
Oh, yeah. Hello. Can you hear me?
Adam. Yeah. We can hear you.
Okay. So, welcome, Dr. Adam. So now we will start our last talk of our conference. So this will given by Dr. Adam. The topic is improving software processes and doing research at the same time. So let me take the opportunity to introduce Dr. Adam. Dr. Adam is an assistant professor at Gdańsk University of Technology, Poland, where he has been working since October 2012. Between 2002 and 2011, he was a network consultant and instructor at Cisco Networking Academy. He obtained his PhD degree in software engineering in 2011. He also holds a master's degree in management information systems. His main research interests are in empirical software engineering with a focus on software modularity, post-object oriented paradigm, and agile methods. Adam is the founder of the International Conference on Lean and Agile Software Development. He has also served on the program committees for ENSCE and ACM SAC since 2015 and MAD EISD at this since its origin in 2019. So welcome again, Dr. Adam. Now it's over to you, please.
Okay, hello. Thank you very much for your introduction. Let me see. Okay, can you see my screen now?
Yes, we can see Adam.
Okay, okay. So now
Can you open the slides?
let's switch to slides. And can you hear? Yeah. I think you can see my slides now. Yeah. Everything is okay. Okay. So I'm very honored by your invitation to deliver this speech. So thank you very much. And what I'm going to talk about today is a research method that is focused on solving problematic situation in organization and developing scientific knowledge at the same time. Of course, the problem must be non-trivial. Otherwise, the organization is able to solve this problem itself, and the organization doesn't need help from the researchers. But actually, sometimes something that seems to be difficult for an organization, it is quite easy to solve by the researchers. And I will give you an example in the end of the presentation. Okay, so very briefly on research method in software engineering. So probably the most well-known method in software engineering is is control experiment. And its main advantage is that we have full control over variables, and we can determine a cause relationship effect. And we use inferential statistic to do this, and this is very powerful. But usually it is very expensive to conduct control experiment in an industrial context. So usually the research environment is artificial and designed just to conduct the study. Besides, trivial experimental units may not reflect the complexity of reality. And on top of that, the great majority of the reported experiments use students as research subjects. And I remember that when I conducted some control experiments, the longest one lasted for something like 4 or 5 hours. And then in the end, the reviewer said, "Oh, you are using toy system in your experiment." Yeah, but then how to use like real big system? And for example, the task is to identify bugs or something like that in this system. So it means that first the subjects have to understand the system. Yeah, so if it is very big, complex system, it is just impossible. Okay, and the limitation of control experiments were noticed by the software engineering community for a long time. And here you can see some of the examples. So for example, Potts called for a paradigm shift from research then transfer to industry as laboratory. And this industry as laboratory concept means that researchers identify problems together with the practitioners and jointly develop a solution in industrial projects. And the need for closer collaboration between academia and industry has been echoed many times by the software engineering community. Okay, actually, software engineering also has a well-known research method to investigate an interesting phenomenon within its real-life context, and this is case study. However, with case study, we go to an organization and we observe how some engineering practice work or why something happens, but we do not try to improve anything. This is just not a part of case study research method. So if we only observe, it means that we do not control or manipulate anything. Yeah, so this is not involved. So to address this call for industry as laboratory, software engineering communities started to adopt action research. And action research is a method that first was used by information system, and only after that it started to be adopted by our community. And action research integrates advantages of both methods. Yeah, it borrows something from control experiment, and at the same time it also borrows something from case study. In fact, action research is more similar to case study. It uses the same technique to collect data. It also needs industrial context. However, with case study, we only observe how some engineering practices are used and whether some method work or not. But we do not try to improve anything. On the contrary, as for action research, we are focused on solving real organizational problems. So to start an action research project, there must be a non-trivial problem that an organization is not able to solve itself. And in action research, we collaborate very closely with the practitioners to improve their situation. And at the same time, we develop scientific knowledge. So action research consists of 5 phases. So first we diagnose what is the problem, what are the sources of the problem. And to do this stage, we have to talk with the staff in the organization, and we have to ask them, yeah, what challenges they are facing. And then after that, we can go to the next step, action planning. And during action planning, we think how to solve the problems that we identified. And we are looking for solutions. And we propose actions that will be taken. And then the next phase is action taking. So it means that we introduce the actions that were planned here. We introduce this action to the teams, to the organization, and then the organization or the teams have to use the proposed actions for some time. They have to use the method or the approach that we proposed. And after some time, we evaluate the results. So we ask the team to tell us whether what we proposed, what they used, whether it worked or not. And if something didn't work or the staff was not satisfied, then we have to think how to improve this. Yeah, so after we collect the result from the evaluation, then we reflect on the intervention, and we think whether we can improve this in the next cycle. Yeah, okay, if everything is okay, then we can finish the project. But if we see that there is something that we can improve further, then we will start a new cycle. Yeah, so then we have to diagnose why some action didn't work or why they work only to some degree. Okay, as for action research projects, this kind of projects can be initiated in two ways. The first way, problem-driven initiation, is most natural, and in this situation, it is the organization who is aware about having a problem, and they know that there is no obvious solution to this problem, and this is why they look for researchers to help them to solve this problem. And the other approach is research-driven initiation, and in this approach, these are the researchers who are in possession of some ideas how to solve some common problems, and then the researchers are looking for settings in which they can conduct their study. Yeah, so this is the researchers are looking for organizations, and they hope that this organization will participate in their research. Okay, and in the next slides, I will share my experience on how to use action research in practice. So I will talk about an action research project that we conducted, and it took us about 1 year to accomplish this project. I think we started this project in 2018, and then for a long time we struggled with the reviewers. But recently we have successfully published a paper. But it was really a long battle with the reviewers, and if we had the knowledge that we gained from the reviewers, the project for sure would be much better, and it would be much easier to get acceptance. So I just want to share some tips with you. Okay, so there were 3 organizations that took part in our research. And among each of these organizations, we selected 2 teams to participate in the research. And the practical objective for the company was to audit and revise the work practices related to the sprint retrospective. Their retrospective, okay, they conducted retrospective, sometimes according to Scrum, like, it should be conducted after each sprint. Sometimes it was skipped, sometimes they were very busy and they didn't have time to conduct the retrospective. So there, for sure, there was an opportunity to improve something. And at the same time, the practical objective was also to teach the staff how to conduct retrospective in a more efficient way, how to get more benefits from the retrospective. And as for us, the research objectives was to find out whether the adoption of retrospective games mitigate common retrospective problems. And we also wanted to find the advantage and disadvantage of different retrospective games. Okay, so before we go further, here's an example of retrospective game. So we start by drawing a sailboat, rocks, wind, and an island. The team is in the sailboat and they want to sail as fast as possible to reach their objectives. which are represented by the island. And usually the objective may be just the sprint goal. As for each iteration, we should have a sprint goal, and this can be represented by the island. And they say, but during their journey, they may encounter risk, and the risk is represented by rocks. The anchor is everything that slows them down, and the wind represents everything that helps them reach their objectives. And then the participants write their ideas on sticky notes and post the notes into different areas according to the picture. And then the participants discuss how to take advantage of the ideas written on the wind area, how to mitigate the risks, and what action can be taken to fix the problems. Okay, so the first phase, according to action research cycle, is diagnosing. So we started by interviewing team members to find out the current adoption of Scrum practices and to identify retrospective problems in the participating teams. And the key findings were as follows. Only 1 out of 6 teams strictly follow Scrum, and retrospectives were implemented improperly and comprised when the team worked under time pressure. So this table presents the common retrospective problems and the degree to which they were present in the participating teams. To summarize, the collected information confirmed that the research problem was authentic and that the participating team were appropriate to implement retrospective games. So we can see that, okay, these are common retrospective problems. Most of the teams in industry experience these problems to at least to some degree. So we asked our teams whether they also whether they have also experienced these problems, and usually they experience. Okay, here we do not have data because this was a new team just created, so they didn't have this knowledge. Okay, and then the next phase is action planning. So as for action planning, we selected 6 popular collaborative games that can be used during retrospective. And we wanted each team to implement each of these games twice. In the end, it turned out that it was not possible. Okay, it depends. Usually, the length of the sprint is like 2 weeks. So it means, and there can be only one retrospective in the end of the sprint. So it means that we can implement one game every 2 weeks. But sometimes the team was very busy. They had some deadlines, and they skipped retrospective. Or sometimes it was the case that some team members were absent. Maybe they were sick or they went on holiday, and then it was impossible to collect data from all of them. So it was better to repeat the game again, or to just not. Okay. The other issue is that after every game session during the retrospective, we distributed questionnaire to collect the feedback, how the team, what the team thinks about this game. Whether whether it is useful, and we ask about different aspects like how it affect their creativity or collaboration, communication, and something like that. So if someone was not one of the team member was not present during this retrospective, then we can't collect data from him or her, and it would affect the quality of our research. Yeah, so this was quite problematic, and in the end, depending whether we have this unanticipated situation, like something was not present. If it was quite common, then in the end we need 1 year to implement these games. And the other problem was also that from time to time some team member may leave the team, and a new team member may join the team, and it is also problematic from our viewpoint. Yeah. Okay, so okay, and we elaborated a generic model of running a collaborative game. This model is based on the state of the art in group idea generation. I don't want to go into details, but in short, each category is processed separately. Processing everything at once is not efficient. Okay, and what I mean by category? So, for example, if we play disabled game, we have category like wind, risk, and yeah, we have this kind of categories. Yeah, so each category is processed separately, and then brainstorming alone is not effective. Yeah, maybe this is against our intuition, but research, there are research evidence that demonstrate this. So brainstorming should be preceded by brain writing, and only then it is effective. And in brain writing, each team member silently writes on separate sticky notes his or her ideas. And only then the moderator reads aloud each note, and it can inspire new ideas, so we can do brainstorming here. And then the team groups related ideas into logical topics, and then the topics are discussed, and corrective actions are proposed. And finally, participants reach a consensus and develop an action plan to be implemented for the next sprint. Yeah, and for each game, we follow the same flow. Okay, so next we introduce the games to the participating teams. And each team attended training on how to play a game before the game was used. And as I mentioned, it took us between 6 to 12 months in each team to implement all the games. And after each game session, the participants were asked to indicate their level of agreement with these statements. And we had 8 statements. The responses were on Likert scale from strongly disagree to strongly agree. And what you can see here are the aggregated results. Okay. So for example, let's analyze this piece of information. So we can see that as for the question, the game should be permanently adopted by your team, And as for say-bold game, one participant of the team, one team member strongly agree with this statement. Then most of the team members somewhat disagree, and one team members somewhat disagree. Okay, and in fact, using this Likert scale and this kind of question is quite common if you introduce something and you want to evaluate how it works. Yeah, usually it is very difficult to use some objective measures. Yeah, the best what you can do is just to ask the staff whether they like the approach or they don't like the approach, and then yeah, if you want to get the opinion, you will use these kind of statements and Likert scale. And then remember that if you if you have categorical data, never ever calculate mean or standard deviation, because in this way you will just give a reason for the reviewers to reject your paper. Okay, I will, so we had, like even more statements, but analyzing these results is not aim of my presentation. In this presentation, I want to show you how to use this research method. Yeah, so this presentation is not about the results, what we achieve. So I will not go into the details. Okay, and then, so first we use a questionnaire to evaluate, but then to gain deeper insights, we also conducted a focus group with each participating team. And we recorded and transcribed each session, and at each session we asked these kind of questions, but of course during the discussion maybe we also ask different questions. Yeah, it depends on the direction of the discussion. And okay, and here is the most difficult thing for the researchers. If you have, because after this focus group, what we have is qualitative data, and qualitative data is quite troublesome to analyze and interpret in a scientific way, because the scientific approach to analyze this kind of data is to apply something what is called grounded theory. And the grounded theory specify 3 stages of coding. First, there is something like open coding, then axial coding, and in the end, selective coding. And this is quite difficult to do. And in this research, we did this in our own way. We use our own approach to coding, and actually the reviewers were not satisfied about this. Okay, so then someone may think, okay, so maybe then just why not only this kind of questionnaire? Yeah, and it is easier because if you have this kind of questionnaire, it is enough if you just visualize the aggregated results, and then you can interpret. But it would not be enough. It would not be enough because here is quite similar to case study. You have to collect data using different techniques and from different sources. Yeah, so if we just use, questionnaire, then for sure the reviewers would not be satisfied. So here you can see data collection techniques that we used in this project. So at the diagnosing stage, we used interview and questionnaire. And as for this interview, it was not structured interview, it was unstructured interview, and we didn't have an interview protocol, and it was also a weak point of our research. And the reviewers again didn't like this approach, because it was just informal talk with the staff, and we even didn't have any notes from these talks. So reviewers didn't like this. Okay, and another important thing is that if you conduct action research project, one of the data collection technique that you must use is participant observation. Participant observation, because the researchers, when we are doing the research, we are like a part of the team. We work together with the practitioners, so we can observe what is going on, whether some approach, some method or technique works, and why the other one do not work. So this is participant observation, and we did this, but again, we didn't know that we should make notes. If we observe, and if we observe something interesting, then we should make something what is called field notes. So it should be a date, exact date, and what was the situation, the condition in which we observed something, and what we observed. We should some like formal evidence. Okay, and then in the end, during the evaluating stage, this is what I've just mentioned. That first questionnaire and then focus group. And the focus group, is important because then we have this qualitative data to analyze, but it should be done in a formal scientific way, and then it will be much easier to get acceptance. Okay, and the last phase of action research is specifying learning. So overall, we found out that collaborative games are usable and useful, but the hype around them is exaggerated. Actually, Agile coaches promote them very heavily, but according to our results, they are helpful, but you shouldn't expect that it will be a breakthrough or something, if you use them. But of course, they improved meeting diversity. It was not so boring, and by using different game, we can look at the past sprint from different viewpoint, and it helped to generate more ideas. For sure, the games also encourage equal participation. Sometimes someone is shy, and if we just discuss, these shy people will not voice out. But if you give them sticky notes and they have to write something, and then for sure they will write. And retrospective games also structure the meeting as well as the discussion, so it was also very good. As for teamwork qualities, collaborative games improved communication and motivation. These two factors were improved the most. And since the issues that a team deals with may be different in each sprint and project, Scrum Master should have a set of possible games to be able to pick the most effective one depending on the situation at hand. And actually, there was no single game that would satisfy a whole team. And there was also no single game that would give the best result in all the cases. Okay, and the other part of specifying learning in our case was to identify advantages and disadvantages for each game. Yeah, and in the end, we think that the game that performed the best was Sailboat and Starfish. Yeah, they were the most appreciated by the team members. Yeah, of course, the one that the one that actually received the best feedback was this one, but actually this is a not real retrospective game. Yeah, it can't be used alone for a retrospective meeting, because this game will not allow the team to collect the feedback from the last sprint. It will only improve the mood among the team members. Yeah, this is to just give to thanks the other team members if they helped, if they were helpful. Yeah, to Okay, and then so now I will talk about the other action research project that I conducted, and in the very beginning of the presentation, I told you that sometimes something can be difficult for organization, but actually very easy for the researchers to solve. Yeah, and this is this example. So this project was run in an international company, and this company has offices all over the world, including India. And the company wanted to have its own big data platform. And the idea was that this platform would integrate different open source frameworks and provide very high level interface for data scientists. And 6 Scrum teams were involved in this project. Yeah, and so they had to collaborate among themselves. But as you know, Scrum doesn't specify how to manage multiple teams working on the same product. Yeah, Scrum was designed for small team, including up to 9 team members. So the Scrum Masters from these teams reviewed different agile scaling frameworks and decide to implement Nexus. And they choose Nexus as it doesn't tamper with the corporate structure. These issues were defined by the headquarters, and the local authorities were not empowered to change it. Yeah, because this company it has its own hierarchy and the way of reporting, and something like maybe the most well-known and major scaling agile method is SAFe. safe, but safe goes very deeply and change the organization, how it is structured and organized. So although it is the most mature and well documented method, and there is a lot of courses and training on this method, it was impossible to use this in this context. And the same was when it comes to other methods. So to do not violate these constraints, they decided to implement Nexus. However, after implementing Nexus, there were still a lot of problems with inter-team communication and work synchronization, and it turned out that Nexus just slightly extends Scrum, and it was not enough. And they didn't know what to do and how to solve this problem, because as I said, other frameworks require changes at the organizational level, which was not acceptable by the headquarter. So they asked us to help them. Actually, we had quite close collaboration with this company, and they gave us for free high-end servers. Actually, it was a cluster of high-end servers, and they just wanted us to use their platform, and they wanted us to teach our students how to use their platform. And then they ask us for help, and then okay, so how we started, so okay, we just follow the action research cycle. So first we identify the sources of the problem, and after that we analyzed how other frameworks, including SAFe, how these frameworks address these issues. And it was we knew that it is not impossible to implement the whole framework, but what we did was to pick up single practices from other frameworks and empirically tried whether it worked in our context. So we thought, okay, what practices from which framework we can introduce to our teams to solve the identified problems. And then after some time, we use this practice for a few iterations, and after a few iterations, we evaluated the practice, and we asked the staff what they think, what are their opinions. And on the one hand, the developers were satisfied that their opinions were taken into account, and on the other hand, we were satisfied that we collect data that can be used in the paper. And we followed, and actually this is Agile approach to improve something. Agile approach is focused on investigating something in an empirical way. So we don't know whether something works before we start to use it, and only after we use we know whether it works or not. And if not, then we will choose something else, and we will try something else, and we will evaluate And in this way, we just develop our own scaling Scrum method that is appropriate for this context. Okay, so if you work in a development team, for sure, there are engineering practices or software processes that can be improved. So I encourage you to employ action research to improve your workplace. And if you use action research, it will be done in a systematic way. So at the same time, you will be able to prepare a research publication. So to make it easier for you to start with this research method, I will prepare a package, and this package will include some examples how to conduct action research and also materials on action research. And okay, I will do this today in the evening, and then I will send a link to the organizer, and I will ask the organizer to distribute this link among you. So thank you very much for your attention. And now, yeah, if you have any question.
Adam, sir, can I have your mail ID?
Yeah.
Because my research is on Agile software development. I have few queries to discuss.
Yeah, okay, but you want to discuss, okay, you want to discuss it privately or now?
Sir, now it won't be possible. That's the reason
Yeah,
I'm
of course.
requesting for my.
Sure. You can contact me. Okay, I will use chat to give you my email, and then we can arrange a meeting. Yeah. So yeah. Very Adam. Yeah. So this is my email. Yeah. So just write to me, and then suggest when you are available, and then then we can discuss.
Okay. Thank you, sir. Thank you so much.
Any other questions? Anybody has any question? So thank you very much, Dr. Adam, for a very, very informative talk, and it will definitely help all the researchers who are keen interest towards this area of research. So thank you very much again.
Okay, thank you very much. It was very nice to be with you.
Dr. Basa, we can have a group photo.
Yeah.
Everyone
So
can
just
turn
now,
on their camera.
So I request all of you, all the participants, to kindly, if you please, on your camera, so that we'll have a group photographs. For a moment, please.
You can take 2-3 snaps, Dr. Basa.
Yeah. Already taken. So thank you. At last, I would like to give a formal vote of thanks on behalf of our computer science family. From my bottom of heart, I thank to our Honorable Vice Chancellor, Sir, Chairman PG Council, Sir, Dr. Santosh Kumar Sahu, Sir, for their wholehearted support to organize this conference. I thank to all the speaker, particularly Professor D.P. Mahapatra, Sir, Dr. Adam, Dr. Rasul, and special thanks to Dr. Godbole, Sir, I think without him, I don't think it could be possible to organize such a nice conference. So thank you very much, Dr. Goodbole, for your wholehearted support.
It's my
Uh,
pleasure. Always for
Thank
you.
you, thank you, thank you. And I also thank to my colleagues, Dr. Parthasarathi Misra, Dr. Minaki Sahu ma'am, for their kind support, and also my students, dear students, who also supported me a lot technically and in every respect to organize successfully this conference. And last but not the least, I thank to all the participants, without whom I don't think it is possible to organize this conference. So I thank from my bottom of my heart to all the participants who are giving their spacious time, although this is a working day, but still they managed to attend whole day conference. So thank you again. Thank you all. And I'll send the certificates to the participants within a week. And also I share the slides through emails. So thank you. Thank you again.
Thank you, Adam, for joining us.
Thank you, sir. Thank you, sir.
Thank you, Dr. Karma and other organizers. Thank you, all participants. Have a nice time.
Thank you, Adam.
Thank you, sir.
Bye bye. Bye bye.
Sir, sorry,